Okay, we can't completely talk about this space right now in the time we had in class and in the time we're going to take here in this video. But we can get a good idea of what's going on. So we want to talk about the space of continuous functions defined on the interval 0, 1. Okay. Now, any continuous function on the interval can be represented by a graph. And the graph can't have any breaks in it. It can be jagged, it can do all kinds of things, but it can't jump from one value to another without going through all the values in between. So this might be a typical function defined on the interval. At least this might be the graph of a function. It's going to be helpful to understand why this is a vector space if we know how to add the graphs of two functions. So, now this is implicitly 0, this is 1. I didn't write it down because we were pressed for time. Would have been easy to write down. So my f function is just going to be a straight line function from here to here. And my g function will be a straight line function from here to here. Okay? Don't pay any attention to what I've got down here. That's something different. We'll get to that in a minute. So how are you going to get a graph of f plus g? Well, I had to step out to pick up some copies that didn't get printed earlier. My fault. I just had to step out for about 3 minutes. I let people puzzle over this. And I came back and people were still kind of confused. They didn't know how to add, because nobody ever teaches how to graphically add two functions in a pre-calculus course. I think nobody but me has ever done it in the history of pre-calculus. And that's wrong because people have. I'd say it's less than 1% of the pre-calculus courses taught in the last 40 years. And more, and between 40 and 20 years ago than in the last 20, when I don't think anybody has even thought about doing it. But I'm sure people have. Just other things to do. It's kind of disappeared. So I'm reappearing it, because we really need to understand this. And it's actually pretty easy, but you got to start kind of slowly. Well, we had a couple of ideas, but the one that really kind of works says, well, okay, add the values of the functions over here at 0, and add the values of the functions here at 1. And if these are straight lines, we can just then get a straight line between the two resulting points. And that was an excellent idea, so that's not what I was going to do, but I can still do what I was going to do, so I really like that. Now that only works if you have linear functions, though. So it's a limited thing, but it's a good way to begin to understand. So what I did, let's see, I had a compass. Yep. So I'm actually going to do this with a compass, assuming I can open the package and manage this without stabbing myself, what I just about did. Okay, so here's our f function, this one. And what's the value of f when x equals 0? Well, it's the y-coordinate. This is a graph of y equals f of x. So f of 0 is just represented on this graph by this distance, the distance between here and here. So if I start at the value g of 0, which I haven't labeled, but right here is the value of g of 0, and add the value of f of 0, I get up to here, and now the y-coordinate is f of 0 plus g of 0, which is f plus g of 0. Okay? Now, I can do the same thing at 1. Now, I chose to, use g of 1. And in both cases, I chose the wrong one. I actually wish I'd have gone back and done it otherwise. I'll do that for you real quickly. Okay, so right there is a distance that represents the value of g of 1, because this would be the point where x equals 1. If this is on the function graph of g, the y-coordinate will be g of 1. Okay? Now I add this to f of 1, which would be represented by the y value at this point, and I get this y value here. So now I have this point and this point that lie in the graph, and if these are straight line graphs, I'm pretty much done. I've just got to connect these two. So I've raised the g function by values equal to the f function, or we could say I've raised the f function by the values of the g function. Let me quickly do this. I don't know why I did that. But let's say, okay, 0's here, 1's here, and that line I just erased doesn't exist. And here's our say this is our f function. Now these functions are going to be a little different than before. I'm illustrating the procedure. And here's our g function. In this case, the g function goes down slightly. Okay, how would I add these two functions? Well, it's 0. My value of f of 0 is just this distance. My value of g of 0 is from here up to here. So my value of f of 0 plus g of 0, well, we just put the f of 0 on top of the g of 0, and we get this. So I can say, okay, we take this distance and we slap it on top of the g. Okay, this line having the same length as this one. And this will be the point on our graph of f plus g. Then, I'm going to take whichever one's lower, which I should have done in the first place. Right there's the value of f at 1. I add that to the value of g of 1, which is the distance from here to here, and I get to this point. Okay, so I've added this distance. I can represent that by an arrow, and I can make this into an arrow. Okay, so the arrow here represents f of 0. It's added to g of 0. The arrow here represents f of 1. It's added to g of 1. And now I can sketch my graph of f plus g. Now we're only defining the graph between 0 and 1. Being a linear function, we see how it would extend beyond 0 and 1, to the left of 0, to the right of 1. But we get some inkling of how we add the graphs of two functions. Now let me just do a couple of points for these two functions. Okay? So I just pick an x value. So I picked this x value. Now, the lower of the two functions has a value represented by this distance. I add that vertically to the value of the other function for the same x value. In other words, I'm doing everything on the same vertical line, and I get this point. Then I'll take this one again. There's the value of the lower function. That's one function. Doesn't matter whether it's lower or higher, but we'll use the lower. And I add that to the value of the other function, and I get a point here. Okay? I can, just for demonstration, something's coming loose here. Tighten it up before it stabs me. Things are pretty sharp. So if I've got this point, what do? Well, I want to take the value here, which I'll represent by an arrow, and add it along a vertical line, a dotted line that I'll mark here, to the value of my g function for the same value of x. So I add this to this, and I get a point here. Okay? This point shouldn't be as high as this one, but if you do it right, it won't be. Because, you know, this is much higher than this, and this is about the same as this. I don't know how I came out that high. Let's see how I did that. I guess I forgot to reset my stupid compass. Okay. So really that point should have been here, so let's just kind of smudge that out. That makes a lot more sense. Okay. Now you do that for a bunch of points and select your points carefully so you get most of the important behaviors of the function, and you're going to be able to sketch a graph of the f plus g function. Now for a couple more points, I'm thinking we're going to get a point about here. From these two, I've got to raise that one up to about here. This goes pretty level here. This rises just slowly as this descends. So I think, I don't know. I don't want to think that hard about it right now, although I can. So the sum of our two functions might be this. So if this function is f and this function is g, here's our f plus g function, at least represented graphically. Now we'll continue, because what we want to establish is that the space of continuous functions defined on a closed interval of the real, the x-axis, let's say, and I chose the interval from 0 to 1. It could have been any interval, but it's kind of a standard interval. Don't want to say any more about that, but we want to show that this is a vector space. It is, okay? And we can see, at least from this picture, that we can always add two functions to get another one, okay? And also addition's commutative. It doesn't matter whether I add the lower one to the upper one or the upper one to the lower one, or it doesn't matter in which order I add the two, I'm still going to get the same coordinates. It's associative. If I have three of them, I can add two and then add the third, or I can take the first one and find the sum of the second and third and add that to the first. Those properties come about pretty easily. Getting our zero function, our inverses, and scalar multiplication are not difficult, but we want to develop a little more insight into the graphs of functions before we can really discuss that well.